One of the most common questions that we hear was how do I know when I need a worm in gear, and how long do gears last? And it certainly raises up a lot of questions. If we look in different books, and many of the technical books, especially gear books, they talk about service life of gears. Okay? Now, service life of gears really have an effect on many different areas, but we've kind of broken down in elevator terms. First of all, we're going to talk about excessive wear patterns. Certainly that's going to affect the life of the gear. And we're also going to talk about fretting, which is when a gear shows signs of fretting. Certainly noise and vibration, even misalignment, has a lot to do with how a gear is going to perform in the service life of a gear. And we also put a term in there, the old lost motion term as well. First thing we have to do is really learn a little bit about gears and some of the terminology of gears. So what I've done was, again, open up some of the books for some different aids. And most of the time when you look and try to find out about worm gears, they'll almost always start off with a regular spur gear, which is a straight tooth gear. Now, a worm gear is nothing more than a variation of a spur gear. And all of the different terms, the gear tooth terms that we use for worm gears start off with spur gears. And I'm sure that there are a lot of different things that a lot of different terms that you've heard throughout the years, such as the pitch of a gear tooth. So it's a very common term. People have said, well, I can see that the pitch is off on the gear teeth. What we're talking about when we talk about pitch, in this case we call it circular pitch. And a pitch is a point on one gear tooth to an exact corresponding point on the opposite gear tooth. That's known as circular pitch. It could be measured. In this case, it's measured on what they call a pitch line. Pitch line is a theoretical line where two gears actually mesh, okay? This pitch circle is where they're measuring the circular pitch. But the circular pitch very often on worn gears is very difficult to determine because the gear teeth are worn. So what we try to do is we try to measure a point that has not been worn out. And we certainly can get the same circular pitch if we measured from this corner over to this corner, or this corner to this corner. You can go by any particular point and measure it over to get generally a pretty accurate sizing of the circular pitch. Okay? The next area that you probably, or a term that you probably have heard of, is that the gear is bottomed. I don't know if you've ever heard that, hey, the gears are bottomed out. Okay. What we're talking about is a situation where, if you notice here, it shows, or it actually terms it bottom land. Okay? This would mean that there is an area here where the tooth of one gear that's meshing with it is hitting down the bottom here, or this particular gear is hitting in the bottom of another corresponding gear tooth. All gears have a built-in clearance. If you notice, it even shows it right here. This clearance is already built in when gears are new. As gears get older, as bearings start wearing, as things start happening in that gearbox, it allows the teeth to get closer and closer together, and before you know it, you have a bottom gear. Very often, a worm-geared machine is a forgotten item in the whole elevator system. As long as there's gear case oil in there and it's not bothering anybody, most people just leave it alone. But as time goes on and things wear, you might find that a maintenance man might come up with a fuse popping or an overload popping on a controller or what have you. And it's usually because these gear teeth are binding up. And usually on a hot day it may come up, or a cold day it may come up, only on extreme situations where you see a situation where the gear might be rumbling as well. You might hear some noise or vibration coming out of it. All of this would indicate that you probably have a worn out section of teeth, and worn out bearings, and now it's at the point where some attention has to be made to it. If you also kind of notice, there's a few other terms in here that you may not have heard of, which I'd just like to very quickly go over. They have something called an addendum and a dedendum. And it just takes the very top of the tooth of the gear and it cuts it right off at the actual pitch circle. And then the lower portion would be called a dedendum. Well, the dedendum is a very important term, and what we try to do when we make our gears is come up with a term called a double dedendum. That means that we put a double clearance down on the bottom of this gear tooth. We make our gear teeth a little bit deeper than normal. And the reasoning behind that is that if after a certain period of time you need to move the eccentric in order to drop the gear teeth in a little bit closer, the only way of accomplishing that is by what we call undercutting the worm. Undercutting the worm means that we're taking some material away from the worm so that we can drop the gear teeth in a little bit further. Now, this was a very, very common thing on some of the older machines many, many years ago because of the size of them. They were so massive, so big, the components being very, very large, that you were able to take a little bit of material out and get it operating again. Certainly, machines today are a lot smaller, a lot more compact, for a whole host of different reasons, which we're going to get into. But we came up with this double dedendum so that this way, if you do start wearing some of your teeth out, and you do get some slop in those gear teeth, you're able to move the eccentric and drop it down without having to pull the worm out and undercutting the worm. So it's just something that you should be aware of. If we're making a replacement worm gear, it really depends on the configuration of the teeth and what have you, but we do try to incorporate that because there have been many manufacturers that have made eccentric shafts, and which is a wonderful feature. However, they don't allow to move that gear further down into the worm without removing the worm and undercutting it, okay? And then there are some limitations on whether or not you can undercut or cannot undercut. If you notice by some of the sizing of these worms that are on the table, there's a very large one. That large worm has been undercut twice. And it hits the point of no return where you can just keep on taking material out, you start changing all the angles, and it doesn't work successfully. That's why it's on the table, because it didn't work. And we can show you some different areas of undercutting, good and bad. It also brings into light that why, for instance, were the machines so much bigger years ago and so much smaller today? And years ago, this industry responded to the way architects built buildings or designed buildings. Buildings were designed years ago to last 100 years. By today's standards, and certainly elevator equipment was designed to last 100 years as well. By today's standards, when they put buildings up, architects usually have a lifespan of about 30 years. So it took the elevator industry a long time to sort of downsize its equipment because it only had a lifespan of about 30 years. So that's why we've seen such a downsizing of equipment by today's standards. If you've ever pulled out a big, large machine and saw it replaced with a much smaller machine, you say, wow, something's wrong here. There really is nothing wrong. The machine is designed to do a certain duty and speed. It's just that it's not really designed to have that endurance that the original machine that was there had. So you're going to see all the downsizing of components. And also, the materials that we use today are much better than materials that they used years ago. So we ask the machine to do more, a smaller machine, and certainly the components and the metals that we use today are one of a better quality. So we're able to do a whole lot more as well.